Okay, 8th graders, this is the practice test that goes along with your general math test 9 and 10, which you're taking tomorrow. So you can follow along and copy the problems as I do them, or you can just check your work, but this is your way to make sure that you're showing all of your steps and getting your problems correct. So let's take a look at the problem. This would be on your FA9 practice test. So again, pay close attention to what they're asking of you. This one is discounts and markups. So knowing that, we know that we're either adding and subtracting. If they're marking up, we're adding. If we're discounting, then we're subtracting. So apples are normally priced at $1.60 per pound, and they are on sale for 50% off. Find the sale price. So that means they're being reduced 15%, which is a discount. So we're going to take, and our question is, first we have to say, what is the 15% of the $1.60 per pound? And when we find that amount, then we can subtract it. So X is what? Is equal to 15% is 0.15 times 1.60. And over off to the side of my paper, I might do my math of 1.60 times 0.15. And I have 5 times 0 is 0, 5 times 6 is 30, carry my 3, 5 times 1 is 5, plus 3 is 8, hold my place, 1 times 0 is 0, 1 times 6 is 6, 1 times 1 is 1. And when I add, I end up with 2400, but I need, take a look, I need 1 2 decimal places, 3 4 decimal places. So that puts my decimal right here. So that means that my X is 0.24, but what I've really solved is I've solved for what 15% off is, which means I still have a second step. So this is really the discount that I have solved for. And now to solve the real price and figure out how much they're going to be on sale for, I have to take my $1.60 and subtract the 24 cents that they're being discounted. And I'm going to need to borrow. So I end up with $1.36. And this is my sale price. And notice how I'm labeling things along the way and boxing my final answer. Okay? Now let's move on to number 2. It's calculating a percent of increase or decrease. The video game originally cost $48.50. David bought it last week for 20% off. How much was deducted from the original price? That means we want the decrease amount. So we're asking, what is 20% of $48.50? And so what is X? Is equal, 20% is 0.20, of is times 40. Okay, so this is problem number 3, and we have to convert it to algebra. So we're going to say 17 is means equals, 25% we read as 0.25, of means times, X is our what? Our question word. So now, because X is being multiplied by 0.25, I really want X all by itself. So the opposite of multiplication is division. So I'm going to say 0.25 that I'm going to divide by. And what that's saying is that 0.25 divided by 0.25 is an equivalent form of 1. So I'm left with 1x on this side. But if I do it to one side of the equation, I have to do it to the other to maintain its balance. So that means I have to divide 17 by 0.25. So over off on the side of my paper, I'm going to set it up. 17 divided by 0.25. Now in order to solve this, I usually move my decimal 2 places to make a whole number, and if I do it to one number, I have to do it to the other number. So I set up my problem. And now I'm going to say 25 goes into 17 0 times, but 25 goes into 170 6 times, and 6 times 25 is 150. And I just know that because I'm thinking quarters. 4 quarters makes $1, 6 quarters makes $1.50. So when I subtract, I get 20. And now I bring down my 0. 25 goes into 200 8 times. And again, I'm thinking about dollars. In $1, there's 4 quarters. In $2, there's 8 quarters. 8 times 5 is 40, carry my 4. 8 times 2 is 16, plus 4 is 20. When you subtract, you get 0, which means that my x is really equal to 68. So 17 is 25% of 68. And I have my answer. Okay, let's move on to number 4. So for number 4, they're asking us to fill in our chart, which is basically converting fractions, decimals, and percents to the other forms. So 3/4 is that fraction that I'm supposed to know. 3/4 is that really common fraction that I know is 0.75. But if you didn't remember that you can take the numerator, the top number, and divide it by the bottom number. 4 goes into 3 0 times. But 4 goes into 30 7 times. And 7 times 4 is 28. And then I bring down a 0, and 4 goes into 20 5 times. 5 times 4 is 20. So that's how I solve to get it as a decimal. And then, from a decimal to a percent, I'm saying take that number and multiply it by 100. So remember, with the endings in 0, you can put your zeros down and then multiply. 1 times 5 is 5, and 1 times 7 is 7, and I have 2 decimal places. So I get 75%. So to go from a decimal to a percent, you're really taking that decimal and moving it 2 places to the right. And here it sits. All right, so now let's look at number 0.64 to a percent. If I move my decimal, I get 64%. And I read 0.64 as 64 hundredths, which is what 64% is. 64% is 64 over 100. But I have to simplify. I can see that they're both even numbers, so I'm going to divide by 2. 64 divided by 2 is 32, and 100 divided by 2 is 50. They're both even numbers, so it's divisible by 2 again. 32 divided by 2 is 16, and 50 divided by 2 is 25. Well, 25 is really 5 times 5, and 16 is 4 times 4, so they have nothing in common, so that makes them simplest form, and I can write them in my fraction box. Now I'm on to number 20, to the 20%. And 20%, if I move that decimal in the opposite direction 2 places, I end up with 0.2 or 0.20. Either one, it's the same. The 0 is just a placeholder. So 0.2 or 0.20. Well, 0.2 is 2 tenths. 0.20 would be 20 hundredths. Same thing. Okay? 2 tenths reduces to 1/5 because they have a 2 in common. And 20 hundredths, first you divide it by 10, and you're left with that 2 tenths, which reduces to 1/5. So this as a fraction is 1/5. Now what I want to remind you of is that if you are given a negative, like negative 3/4, that would make your decimal negative and your percent negative. You do all the steps the same, but you have to remember that negative. If 20% had been negative, then the decimal 0.2 would be negative, and the fraction 1/5 would be negative as well. Okay, let's move on. Number 5 says, list the numbers in order from least to greatest. So in order to do that, I really recommend converting them to decimals. And we know that 3/4 is 0.75 because we just did it up here. And 4/3, I need it as a decimal. So 4 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. When I subtract, I get a 1. I need to bring down a 0, which means that I need to show that decimal place. 3 goes into 10 3 times. 3 times 3 is 9, and I get another 10. So that means I'm getting this repeating 3. So 4/3 is 1.33 repeating. So usually what I do is I take my biggest number, 3.4, and I put it way over here. And I take my smallest number, 0.34, and I put it way over here. And now I figure out what goes in the middle. 0.75 is definitely smaller than a whole. and the whole 0.33 is next. And this is my answer from least to greatest. And all of this other stuff is my work, and that's the stuff I should be seeing. All right, let's look at the next page. Okay, so this is, again, same type of problem, except that it combines the chart and the ordering from least to greatest together. Okay, so 3/5. I'm going to take 3 and divide it by 5. 5 goes into 3 0 times, but 5 goes into 30 6 times. So 3/5 is 0.6. And now if I want to convert it to a percent, I move my decimal 2 places and I get 60%. So I'm going to take this 0.25 and I'm going to move my decimal 2 places and I get 25%. Well, this is one of those numbers that you're supposed to know. 0.25 is 1/4 out of $1, 1/4 out of 4 quarters. That makes it 1/4. Okay, 30% is 0.30 because I've taken my decimal, which is here, and I've moved it 2 places to the left. And 30% or 0.3 or 0.30 is 3/10. Okay, you can either say it's 3/10 or you can say it's 30/100. But either way, 30/100 has a 10 in common, so it reduces to 3/10, which makes it the same number. Okay, which is what we're proving, equivalency. 3/10 is reduced, so this is your fraction. Okay, now we have to order them from least to greatest to the right of the chart, which means in this space here. Now, I'm going to do it the easy way. I'm going to use the percents and say that 25% is the smallest, then 30%, then 60%. Okay, but if I had to use the fractions, 25% is 1/4. 30% is 3/10. 60% is 3/5. And I would have answer in that form as well. Could also do it with the decimals, 0.25, 0.3, 0.6. Okay, let's move on and look at the next one. Okay, so we're moving on to practice test 10, and the first problem is a commissions and profit problem, which is our newest concept. Pretty much problem 1 and 2 are our newest concepts, and the rest is just repeat. It's just same types of problems that we've been doing in the past. So let's take a look at number 1. It says a car salesman sold $12,000 car last month. His commission rate was 7%. Find the dollar amount of his commission. So he's on the commission just like those real estate agents that we talked about. So what we're asking is, what is 7% of $12,000? And when we know that, we know what his commission is. So what is X? Is equal, 7% is 0.07 times 12,000. So we need to do the math. So some of us can do this in our head, some of us can't. So you can come over to the side of your paper and you can multiply and solve for the answer. Or you can say, oh yeah, I remember. When we're multiplying with things that end in 0, I can write the zeros, which there's 3 of them, so I wrote 3 of them. And 7 times 12 is 84. And now I just have to remember that there are 2 decimal places. So I put my decimal place right here. And so that makes X equal to $840, which is his commission. That's how much he made off of selling that $12,000 car. Okay, and I'm looking for these steps, and I'm looking for you to write what it actually means. All right, number 2, Mr. Smith deposited a principal of $160 into a bank and received an interest rate of 1.5%. Using the formula I equals PRT, determine Mr. Smith's interest earned after 4 years. Well, 2 hints. 1, they called it simple interest. And 2, they gave you the simple interest formula, which means take the formula and write it. Whoops, made a mistake. Interest equals P, principal, times rate, times time. Let's plug in what we know. We're we're solving for interest. The principal amount was 160 times a rate of 1.5%, which is 0.015, times 4 years. So I might be able to do some of this in my head. I might not. Okay, I'm going to do 4 times 160 first. So 4 times 0 is 0. 4 times 6 is 24. Carry my 2. 4 times 1 is 4, plus 2 is 6. So that's 640 times 0.015. And now, this is a little bit harder. So I'm going to bring it over to the side and say 640 times 0.015. 5 times 0 is 0. 5 times 4 is 20. 5 times 6 is 30, plus 2 is 32. Hold my place. 1 times 0 is 0. 1 times 4 is 4. 1 times 6 is 6. I'm going to add. I'm going to remember that I have 3 decimal places. 1, 2, 3. So I really have 9.60. So interest is equal to 9.60. So that means he made $9.60 for his interest. Okay, Mr. Smith's interest was this. So $9.60 is Mr. Smith's interest. And I'm going to box my answer. Okay, now let's move on and take a look at number 3. Number 3 says, discounts and markups. Apples are normally priced at $3.50 per pound, and they are on sale for 20% off. Find the sale price. Well, since it's sale, we know it's a discount, which means that we are subtracting. So our question is, what is 20% of $3.50? Convert it to algebra and solve. 2 times 0, so I can put my zeros. I got 2 zeros. Now, 2 times 5 is 10, carry my 1. 2 times 3 is 6, plus 1 is 7. But think about how many decimals I have. 1, 2, 3, 4. So that means 0.7000. So in dollars, this would be 70 cents. Okay, that's what? Is that the answer? Is that the sale price? They're selling them for 70 cents a pound? No, this is the discount. So in order to find the sale price, I have to take my original amount and subtract the discount they're giving me. And I do have to borrow. So I end up with $2.80. And so I want to make sure that I write that this is the sale price, and I box my answer. All right, moving on to problem number 4. We are calculating a percent of increase or decrease. Sally bought a sweater for $46.75 that originally cost $85. What was the percent of decrease from the original to the sale price? So this is that formula that we want a percent of decrease. So our formula is the percent of change is equal to new minus original divided by original. So the percent is equal to the new amount, which is she bought the sweater for $46.75. That's the new amount. And it originally cost $85. That's the original amount. Now think about this. It was $85. It's now $46, which means it's a decrease. So our answer should come out negative. We're dividing that by the original, $85. So my percent of change is equal to $46.75 minus $85. So let's subtract $85 minus $46.75. Well, I do have to borrow. That was a 10, and now I'm going to make it a 9. Borrowed from here. I'm going to need to borrow again. So 10 minus 5 is 5. 9 minus 7 is 2. 14 minus 6 is 8. 7 minus 4 is 3. And the 85 was the negative, so this is negative 38.25. and I'm dividing it by $85. Well, that's not yet a percent. That's a decimal divided by a decimal. So what I really have to do is I have to do some long division. So I need to get out my math and say, all right, well, we know it's going to be a decrease, but we've got to figure out what it is. It's 38.25 divided by 85. So let's think about what it could be. All right, so 85 goes into 382. Well, it doesn't go into 38, so it goes into 382. I'm going to guess about 4 times. So 4 times 85 is equal to 340. And when I subtract, don't forget I have this decimal up here. When I subtract, I get 42. So I'm going to bring down that 5. And 85 goes into 425 5 times. 5 times 5 is 25. Carry my 2. 5 times 8 is 40, plus 2 is 42. So my answer is 0.45. So let's take a look at what we have. We have the percent is equal to negative 0.45. Well, is negative 0.45 a percent? No, it's a decimal. So what we want to say is, all right, we're really moving that percent over to the other side, which makes us a negative 45% change. Okay? All right, let's look at number 5. What is 400% of 56? Well, 400% means it's getting bigger. So I know my number has to be bigger than 56. X is equal to 400%, which is really 4.00, because look, I move my decimal 1, 2, and I get 4.00. Let me write that a little neater so we can see it for sure. 4.00 times 56. So 4 times 56. 4 times 6 is 24. Carry my 2. 4 times 5 is 20, plus 2 is 22. So that makes my number 224. And remember, I know that I can do this in my head. If you can't, come over and write it off to the side. 4 times 6 is 24. Carry my 2. 4 times 5 is 20, plus 2 is 22. So our number is 224 is 400% of 56. And I boxed my answer. All right, let's look at number 6. Number 6 is our last problem. And again, it's the same thing that we've been doing. And in fact, I think this is the same problem from the last paper. So 3/5, I remember, is 0.6. But let's prove it. 3 divided by 5. 5 goes into 3 0 times. 5 goes into 36 times. Then I move my decimal 1, 2 spaces, and I get 60%. Remember, if this was negative, this guy would be negative, this guy would be negative. 0.25 is supposed to be one that you know as 1/4, but if you need to do it, it's 25 hundredths, because we read 0.25 as 25 hundredths. Tenths place, hundredths place. Well, if we take it to its primes, 25 is 5 times 5. 100 is 10 times 10, which can be simplified to 2 times 5 and 2 times 5. And I can see my equivalent forms of 1, which leaves a 1 on the top, and a 2 times 2 on the bottom, which is 4. So 1/4. And making it a percent, move the decimal 2 places, and I get 25%. 30%, move your decimal 1, 2 places in the opposite direction, you get 0.3. 0.3 is read as 3/10. So I write it 3/10. All right, that's it. And good luck on your test tomorrow.